Thank y'all. Expanding the if statement. We've seen this. This is what's known as a single alternative if, meaning it either does something or nothing. Now, if we were going to get all computer sciencey about it, we would say that if this is not true, that's the null case. And the null case is the case that produces nothing. In other words, anything that is not greater than 90 would not result in an A. Now, to me, that should be greater than or equal to 90. It's kind of a jerky teacher. You make a 90 and he still gives you a B. But that's the way this is worded. I would do this. So this is a single alternative if, but you can have multiple alternative ifs. You can have if else. So it performs one statement or the other, right? If that's true, great. But if it's not true, do something else. If snowing, wear your mittens. Otherwise, don't wear your mittens, right? Print out two messages. If temperature is less than 32, print freezing, else print not freezing. If temperature is greater than 100, turn the air conditioner on, else turn the air conditioner off. The general format, if the expression, do a block or a single statement. If it's a single statement, you don't have to use curly braces, but if it's more than one, you do. Else, do the other. Enter a number, and I will tell you if it's odd or even. Well, how do they check to see if it's odd or even? What they do is they divide it by 2, and if it's got a remainder, then it's odd. If they divide it by 2 and it doesn't have a remainder, then it's even. So how they check to see if it's even or odd? They use modulus, right? So if the number is 4, 4 modulus 2, 2 goes into 4 2 times with a remainder of 0, it would print it even. What if the number was 9? 9 modulus 2, 2 goes into 9 4 times with a remainder of 1. And so we'll come down here and print out that the number is odd, because this case is not true. Since that case is not true, it goes ahead and does that. Like that. If number %2 is equal to 0, great, it is. Print that it's even. Otherwise, print that it's odd. This number asks for the user for two numbers. Num1 is divided by num2 and the result is displayed. But before the division, we test to see if it's 0. Because if you do integer division and you get 0, well, these aren't integers, but you're not going to like what it prints out if we try to divide something by 0. So we check. Enter the first number, they type it in. Enter the second number, they type it in. If the second number, if the divisor is equal to 0, then it's going to be a problem. Division by 0 is not possible. Please run the program again and enter a number other than 0. Sounds good to me. Else, quotient is equal to num divided by num2, and then print that out. Num divided by num2 is quotient. This is called echoing your input. They typed in num1, they typed in num2, and in our output, we're not going to just kick out the answer. We're going to tell them what they entered, so that they can, if they get 0.25, they don't know why they got 0.25. Well, right there, they're going to see that it's a 1 and a 4. They don't even have to scroll up and find out what they typed up ahead. Just like when you're making an Amazon order, you like seeing, your billing statement. You like seeing, where it was being addressed, where it's being mailed, and what it was charged, and how many of each item in the total. It's all echoing your input. You filled in several pages worth of data, and then right there before you click your final purchase button, it displays all that so you can validate it. Nested if statements. That's an if statement nested inside another if statement. In other words, you have an if, and then tabbed over, you have another if. And if you want, you could tab over and have a third if, and you could tab over and have a fourth if. And all of those would have to be true before the case was true. Have a working marker. Let's find out. the tension mounts. All right. Like
Start the recording?
I hope so. I so hope so. Yes, yes, yes.
I'm sorry.
Thank you for asking. I appreciate that so much. Where's the trash can? If, x is greater than 0. And then, yeah, it might be. Curly brace. If x is less than 100, might be. In that case, see out, arrow, arrow, that it's a valid number, because we wanted a number between 1 and 99, apparently. This is a nested if, right? It's inside another if. Nested dolls, right? Russian dolls. You got a little baby doll, and you got the mother and the grandma, whatever, right? So this is an example of a nested if. You can nest ifs inside of else's. You can nest ifs inside of whiles. You can nest whiles inside of ifs, right? You can nest any of these structures inside of any of these other structures. I'm going to make a point about that particular example. We may as well do it in code, which is that sometimes you can replace nested ifs with what's known as an AND logic. In this PowerPoint, we'll get to AND, and I think we briefly broached it before. I'm not totally sure about that. So why don't we start Visual Studio? I'll erase you. I'm going to go grab my boilerplate. So we're on L, check it, L, File, New Project, Lecture L. Go to Solution Explorer, view Solution Explorer if you have to, right-click on Source Files, and I know absolutely everybody already knows that it is. C file, I'm also going to call Lecture L. Capitalizing L because a lowercase l looks like an I, which looks like a 1. All right, now I'm going to paste my boilerplate. I think I had a question about random numbers and making sure that the random number was not the same each time. If you're going to do that, and we'll get to random numbers in a minute. I was on a roll about if statements. Alrighty, so we need to ask the user for a number. I'm going to fake it. I don't feel like asking a number. Right. So int num is equal to 36, right? We could use cout. Int number is equal to 35. We could use cout and get the input, but then every single time we test this, we have to type something in. Now we're going to write an if. If number is greater than or equal to 0 or 1, let's make it so that they have to type in 100. If number greater than equal to 1, close parentheses, curly brace. If num less than equal to 100, open curly brace, and we're going to print out that it's a valid number. Cout, error, error, quote. Good value, man. All right, \n, end quote, semicolon. So what if they didn't type in any of that stuff? We probably want to tell them that they got it wrong. But this is a classic nested if without expanding it. We could expand it, right? We could put an else here. Else, open curly brace. Now I'm really tempted to delete all the curly braces to save our spell space. See out arrow arrow. Well, the number must not be greater than 100. So see out arrow arrow. Num must not be greater than 100. Backslash n. End quote, semicolon. All right, but what if it was less than 1? We need another else case. So down here, we're going to do else, subscript, excuse me, curly brace, see out, arrow, arrow, quote, number must not be less than 1, backslash n. We really ought to let them type it in, right? Just for testing purposes, then we'll comment this out. See out, arrow, arrow, enter a number, colon, space, end quote, semicolon, and CIN, arrow, arrow number. Just so that we can test it several times in a row without having to, modify that number. Alrighty, enter number. I'll bring the code back in a minute. Alright, I'm going to enter a 75. Good value, man. Alrighty, going to run it again. I'm going to try to test all 3 states. -10. Yeah, the number must not be less than 1. Alright, now I'm going to run it one more time. Enter number. 200. Number must not be greater than 100. Okay, now that logic works, but it could be simplified. And if the logic can be simplified, we're usually better off in doing that. How am I going to do that? I'm going to use the AND keyword. Because what this logic really says is if the number is greater than equal to 1 and the number is less than equal to 100, then it's good data. Otherwise, it's bad data. That's going to simplify this considerably. It's not going to be a nested if anymore. We're only going to have one else. We're only going to have 2 messages being printed rather than 3. So in general, that's going to be a good thing. So if number is greater than equal to 1, and now in Python I would use the word and. But we don't have that word in this language. We use 2 ampersands, which is shift 7. And number is less than or equal to 100.
What's the double and again?
Means the word and.
Why double instead of a singular?
Singular means something entirely different, unfortunately. And what it specifically means is you deserve a good answer. It means a bitwise and. And a bitwise and is when it's comparing zeros and ones together. And so we can get back and talk about that. But a logical and is 2 of them. We just have to kind of take that on faith. I kind of like that Python has the word and, but this one doesn't.
What's your preferred programming language?
Oh gosh, I don't know. I'm falling more and more in love with Python. C++ is how I made all my money to begin with. Java is awfully cool. I would say Java and Python. Alright, so, doesn't mean I don't love C++. There we go. So if those things are true, we're going to print good value, man. See out, error, error, quote, really good. Exclamation point, backslash n. Otherwise, we're going to tell them, hey, that's not cool. Now, I really am going to delete the curly braces here, conserve some room. Else, see out, arrow, arrow, num must be between 1 and 100 inclusive. \n. So these 4 lines of code replaced all of this. Now sure, if I deleted these curly braces, this would take up less space. I'm going to go ahead and delete, remove them, and then I'm going to put them back because that makes it a little hard to read. Right. But still, all of this being replaced by this, that looks better to me. So nested ifs can often be replaced with logic that uses the AND operator. Now let me undo that. I'm going to put all my curly braces back. And if you love curly braces, as well you should, then you could also put them here. Right, just like that. If you feel like it, go for it. If you feel like removing them, great. This logic is so simple, unlike the first one, that I think that it's just as clear without them.
So just taking all the curly braces will still, the program will still run?
In this particular case, why? Because we don't have any blocks of code that are more than 1 line long. And so if the statement is just 1 line long, you don't have to put it inside curly braces. But it made this code look pretty weird. Or I guess it made it look like Python. But anyways, right, like that. I've messed something up, so I'm going to undo all that. And let's test it out. I'm going to do the same thing again. I'm going to test it 3 times. With a number less than 1, like 0. Number must not be less than 1. Number must be between 1 and... So both of our if constructs worked. The one using the AND statement worked, and the one that didn't use the AND statement worked. I'm going to run it again and type in 101 because that's a bad value. Number must not be greater than 100. Number must be... So the second and, the second if with the AND statement rather than the nested ifs worked. And I'm going to run it one more time with a valid value, 50. Good value, man, really good. Okay, hope that makes sense. Now that we've talked about AND a lot, but if you have an AND, it means that both sides have to be true before the result is true. If you have money and you are hungry, go out and eat, right? You're not going to go out and eat if you're not hungry. You're not going to go out and eat if you don't have any money, unless you can sponge off a friend, right? So that's what AND means. There's the other keyword, which means OR. With an OR, only one side has to be true. And by the way, the OR is the vertical bar. You have to use 2 vertical bars, which is shift \\, which is the key above the enter key. Probably not going to do an OR right this second. But that'd be like, say your boss is really generous and he'd let you stay home, or she, let's not be sexist, she would let you stay home if you were either sick or tired. And so you could word that, if sick or tired, print stay home. So, are you sick? Yeah, stay home. Are you tired? Yeah, stay home. So that's a different construct, though. That's not a nested construct being replaced with an AND. And by the way, while we're at it, and while we're looking at those double ANDs, here's something I don't recommend you do, because other more experienced programmers will give you, the stink eye for doing so. But what if you really don't? What if you really hate ampersands? You could do this. # define the word capital A and D as ampersand, ampersand. And then down here, you could replace those ampersands like that. You're in effect defining your own language at this point, right?
Could you define stuff like if and else?
Yeah. So like, what if we wanted another fancy word for if, like maybe, right? Maybe means if. So I'm going to come down here and I'm going to replace that with maybe.
Why are those 3 dots under the AN on AN?
Good question. Why are the 3 dots there? The macro can be converted to const expr. Show potential fixes. Alt enter. I don't know. That looks bad to me. I'm not familiar with that, so I'm going to undo that change. All right. This doesn't seem to have worked. Identifier maybe, oh, because it was supposed to be caps, right? And maybe I really hate opening parentheses. So I'm going to define start as being an open parentheses, like this. And so then I'm going to say maybe start, and this is ridiculous, right? Like I said, you're not supposed to be doing this. But I just wanted to show you the use of # define, because so far all we've done with the # is # include. And so I'm going to replace the word stop with a close parentheses, right? And there we go, cool. Yeah, so anybody else seeing this would look at you really oddly. Yeah. Don't need to do that, right? So I'm going to undo all those changes. I just wanted to introduce you to the concept that you can use # define. It's called macro expansion. And gets replaced with the double and signs. The word maybe gets replaced with the word if, and so on. Maybe we'll find a good use for that at a later point. For now, I guess I'm going to comment that stuff out and fix the code underneath. If you didn't type it, great. And so this really needed to be if parentheses, and the and needed to be switched back to that. And the stop really needed to be that. Here's one more that you could define. # define indif, INDIF. And I'm not even defining it to anything, but I can still use it like that. If something else, right? It doesn't do anything. It's a meaningless keyword, but if you're really into pseudocode because you took fundamentals of programming and you really wanted to see an end if and an end while, then you could define those keywords like that. Am I going to do that? Nah, I'm going to delete that. So as far as comments go, seems like I stated it, but I didn't write it down. A series of nested ifs, or check to see if nested ifs can be replaced by quote and end quote logic. Ampersand, ampersand means and. Both sides of the and must be true before or for the result to be true. And this is just showing a nested if in action. Right. If employed is equal to yeah, then we check to see. Are you a recent grad? Yeah, display congrats. You get the special interest rate. Too bad for all the people who aren't a recent grad, right? I didn't graduate last year. I don't get the special interest rate. Poo on them. I'm going to go to a different bank. Anyways, and then since they did not do it with an and, there's two other cases that go through, right? If it's yes, employed, but not a recent grad, then we say you must have graduated in the past 2 years. But if you weren't employed to begin with, we say you must be employed to qualify. We could replace this logic, as I did, with an and. If employed equals yes and recent grad equals yes, print congrats. You got the special rate. Else, print you must be a recent grad and employed. So here's that code, but without any else statements. Here's that statement with else. Are you employed? Yes. Are you a recent grad? Yeah. Print you qualify. else you're not a recent grad, but you are employed, print you must have graduated in the past 2 years. And if none of those are true, the final else, you're not employed, print you must be employed. And I would use an and. I would do if employed equals y and recent grad equals y. The if statement. We talked about dual alternatives, but you can hook up a bunch of if-elses together to create more than 2 choices. I swear I had a notepad open, did I not?
Yeah, but it didn't
It's
have
open,
anything in it. Let's see.
Did I close it accidentally?
Um,
Because I don't see my
maybe.
data. Alrighty, well.
It didn't have anything in it.
Yeah, you wrote on the board, you didn't type it.
Oh, okay, cool. Alright, that's cool. Although, well, I guess we could add this to our code. I guess that's the mode that we've been following. I'm going to do /* to open a multi-line comment, and then // So if, else if can create more than 2, larger than dual alternatives, can be used to create more than 2 alternatives. Alternatives, like if grade or if temperature is greater than 100, it's really hot. Else if temperature is greater than 70, it's lukewarm. Else if temperature is greater than 40, print luke cold. You know, kind of cold. Else it's really cold, right? There, we have 4 different alternatives there. Now we could have written this without else's, but the logic would be a little bit more complicated. Like this, and don't write this down. I'm going to write it and delete it. If temperature is greater than 100, it's really hot. If temperature is less than or equal to 100 and temperature is greater than 70, it's lukewarm, right? And then we could do the same thing down here. If the temperature is less than or equal to 70 and temperature is greater than 40, right? This works the same, but it's a lot clearer. The logic is a lot cleaner to look at if we just do it with else's.
So,
yeah.
In this particular case, if you were to enter a number less than, yeah, it says else if temp is greater than 40, or yeah, this says else is temp is greater than 40, right?
Right.
All right. So if you were to enter a number above of these, like say 75, that would also be greater than 40. Would it print lukewarm and kind of cold?
Excellent question. That's almost an exam question.
But
It would if it looked like this. If we'd written it like that, then if the temperature was 70, is it greater than 100? No. 75, yeah. Print lukewarm. 70 is greater than 40. Print kind of cold. Very good point. But we have else ifs. Meaning, let me rewrite this just a little bit. But I'm going to have to use
third else is misspelled. Or second else.
Ellis. Yeah. All right. Let's fix that.
And down, you copied it too.
Yeah. All right. Maybe you'll just take it on faith that this is correct rather than typing it in all yourself. But what's going on here? Other than the fact that I had too many choices. Okay. These 2 bits of logic are the same. That is 1 bit of logic. is equal to this. Is your temperature greater than 100? Yeah, print out hot. Else, well, it wasn't greater than 100. Is the temperature greater than 70? Yeah, you said 75, so it's lukewarm. Else, well, we're going to skip all the else, right? Because it was handled by that one. So the else if is a replacement for creating this kind of stair-step logic. Does that make sense? Okay.
So what's the difference between that and just the if? So
What?
I see what that's doing.
What if we had just done ifs? If we had just done ifs, then your question about 75 would in fact produce erroneous output like this. If we change these to ifs. Well, this is bad code. But why? Because what if these were grades instead, right? And 70 and above was a B, and 40 and above was a C. Well, 75, we're cooking down here. 75 not greater than 100, we're going to skip that. Is temperature is, greater than 70? It sure is. So print out B. And then is it greater than 40? It sure is. Print out C. Right? Without using the else's, it's not mutually exclusive. We're not guaranteed to only get one result.
So the else only finds the one applicable line, and with the ifs, it goes through every line.
Right, it would check every one of these if we just have ifs. That check is performed, that one is performed, that one is performed, and that one is performed.
Got it.
Whereas, if this is true, then it's going to skip all the rest of this stuff. And if this is true, it's going to skip all of that. Let's go back to the nice clean one. If this is true, then it's going to skip everything else. If that one is true, it's going to skip all of these. If that one's true, it's going to skip that one. And if none of them were true. So it's mutually exclusive cases. One and only one of those is going to get executed. Extremely good question, because that's going to be an exam question. What's wrong with this code? And the answer is going to be something to the effect of it prints out both that you got a B and a C and a D. Something like that. That's going to be the symptom, and the reason why is because you didn't use else. So I'm going to put a comment here down here. Not that I expected you to enter all that, but the above code is bad because if the temperature is greater than 100, it will print really hot, lukewarm, and kind of cold. You use else to ensure that one and only one choice is executed. Use else to ensure that one and only one choice is performed. So that tests a series of conditions until one is found to be true. Often simpler than using nested if-else statements. Can be, which is what I gave you an example of here. These are nested if-else statements. Why are they nested? Well, this if is nested inside that else, and this if is nested inside that else. But there was no reason to do that. We could replace each else open brace with just the words else if. And you Python programmers remember that being elif in your language. So, could you do this? Pound sign define elif as else if. Yeah, you sure could. So if it is raining, take your umbrella. Else, if it's windy, take your hat. Else, take sunglasses. Now, what if it was raining and windy? Doesn't sound right to me. This logic looks a little bit hinky. Letter grades. If your test score is above the A score, print your grade as an A. Else, if your test score is above the B score, greater than or equal to, print out B. Else if it's greater than a C, print the C. Else if it's greater than a D, print to the D. Else print F. If you left the words else off, then a grade could trigger multiples of these. If you made 110, it's probably above the A score, it would print out A, and 110 is certainly above your B. It would also tell you you're under B, and it's certainly higher than a C. Your grade is a C, and so on. It would print every one of these except for the F. At least it wouldn't print the F. That's some small comfort. This is called a trailing else. You can stick a trailing else on there to make sure that the data is just flat out not invalid. If you have a series of if, else, ifs, it's not a bad idea to put a final else statement on there to handle bad logic. Logic that you think may never come up, but it might. So for example, say we had this logic. What was our variable called up here? Num. All right. Just so that we get some real code going again. If parentheses num is greater than 100, cout quote quote large \n. Elif, not elif, that's Python. Else if parentheses num less than 100 ampersand ampersand num greater than 0 cout medium \n. Now I'm constructing this in this way. I'm constructing this in a deliberate way as to introduce an error. Else if the number is less than 0, cout small. Okay, now what's wrong with this code? What the serious thing about the answer, yeah, I'm not going to even tell you what's wrong with it. We're just going to run it. I want to see the number large if it's greater than 100. I want to see the number medium if it's less than 100 and greater than 0. And I want to see the word small if it's less than 0. So if I run it, first I'm going to test it with something I'm sure is going to work. 120. Yep, that's large. I'm going to run it again. And our number, well, okay, 50. It's halfway between our two goalposts. It's medium. So far, so good. Run it again. I'm going to type in a really small number, negative 100. Yeah, that's small. That's cool. All right, now I'm going to break it. I'm going to type in exactly 100. It didn't print out large, medium, or small. My logic is bad. Now, I know how to correct it. But what if I hadn't noticed that? Right? What if my testing had not revealed that bug? Well, I could force the issue, make it reveal the bug, if after all these if, else, ifs, I had a final trailing else. And if none of these other cases are valid, cout error quote. Nah. Unexpected result or unexpected value for num \n. So if I type in 100, it's going to kick that message out, telling me I got it wrong, that my logic is wrong. In our number, all right, 100. Unexpected value for num. That tells me that I've made a mistake in my logic and I better fix it. 0 also triggers the same behavior. 0. Unexpected value for num. So there are two values. Now the problem is that what is the opposite of greater than? It is not less than. The opposite of greater than is less than and equal to. And that would fix that. And then what is the opposite of greater than here? Less than or equal to. That would fix that. And if I made those changes, I would never again see this unexpected value for num. But I wouldn't have even noticed it if I hadn't put this trailing else here. I'm going to undo those changes to fix it. The last message will be printed out for 100 and 0. Or when, oh come on. When num equals 100 or 0. So we should correct the logic to handle those cases. And fundamentally, the reason that we introduced an error is that we made this logic too complicated. We should have just said if number greater than 100, print out large, else if number greater than 0, print medium, else print small. That would have handled it. Instead, we got all fancy and we thought we needed to use an and there. We didn't.
Would either one be counted wrong on the test? Like the
Oh, if you wrote this and you got the logic correct, right? If you did that, then no, I'm not going to count you off for writing code that works. But, like if you're writing that grade program, it's far better just to list your boundaries the way that this did, right? You don't need to do if test score greater than A, print A, else if test score less than A, and test score greater than B, right? And then else if test score greater than B and test score less than C, right? You don't need to put multiple conditions in each one of these to handle this mutual exclusivity. You just check to A, greater than A, print A. Else, if greater than B, print B. Else, if greater than C, print C. Flags. A flag is a Boolean value that is used to trigger something later. A flag is usually implemented as a bool variable, and this language is called bool. In Java, it was Boolean. This language came first. Java felt like they had to be different. It's a variable that signals a condition. Something like this. Bool really underscore big equals, let's write it out the large way first. Bool really big. And then if parentheses num greater than 10,000, then really underscore big equals true, semicolon. Else really underscore big equals false. And then we can use that later on. If parentheses really underscore big, into parentheses, see out, wow, that's really big, backslash n. So this is what's known as a flag. It gets set here and then it's checked later. Oh, that's a flag. Set the flag. And then check the flag. Now this code could be optimized a little bit, and then it could be optimized a lot. If we had initialized the flag to false, then we wouldn't need this else clause at all. And that's typically what you do. If you're going to create a flag, you initialize it to false, and then under certain circumstances you set it to true. So that would have been better logic. Better still is to write it like this. Bool, I guess I'll put it underneath that if statement. Then I better stop and make sure nobody has syntax errors. Bool really underscore small equals, and I'm going to put parentheses here, but the parentheses are not necessary. Parentheses in parentheses, semicolon, and what defines a really small number? Num is smaller than negative 1,000, 10,000. That makes it a really small number. That's what defines this small number. And then if really underscore small inside parentheses, then see out, error quote, wow, that's small, really small. See out, error quote, Wow, that's really small. \n. So we managed to do in 2 lines, well, 3 lines of code, what took us 1, 2, 3, 4, 5, 6, 7 lines of code up there. Now this is a little more terse. But after you've seen it a few times, it's going to be at least as readable as this is, if not more. How do we read it? This is the expression. This is a Boolean expression which returns a false or a true. If number is less than that, it's true. And so true would get copied into that variable. But if number is not less than that, then it's false. And false would get copied into that. So this is storing the result of a Boolean expression in here. Now, could we have just written if num less than -1/10,000 print, wow, that's really small? Yes, you can. But maybe we're going to use that test over and over and over, right? Maybe we're going to check to see if it's really small in 7 different places. You don't want that expression to be reevaluated 7 different times if you could just set a variable and then check that variable. Because each comparison takes, a couple nanoseconds. And, it's more computer time. Nowadays, computers run so fast that we don't really care about stuff like that. But what if we were writing graphics drivers that needed to be super fast to keep your games going? In that case, you do care about things like that. So this sets the value of the flag, and this checks the value of the flag. I will add comments to that effect. The above line sets the flag to true or false, and then this checks the flag. As I mentioned, the parentheses are not necessary. You could take them out, and the code would be just as good. I like the parentheses because they make your eye kind of hone in on it. Textbooks probably wouldn't show the parentheses. Like that. So that's a flag. It's a Boolean variable. You set it to true, and then you check it later to perform something. Like it could be an error state, right? The file was not open, right? Then later on you could do if error, right? Then handle the error however you're going to handle it. Now back in the early versions of the C programming language before the bool data type was created, people would just use integers as flags. Something like this. Int error equals 0, right? And then if some case, if num is equal to -9, say that's a really horrible value. We hate that. That's an error case. Then error equals 1. And then later on we can do if error, then cout error, oops, comma error. Let me scroll this up. I can't believe that y'all can see this far down on the screen. There we go, like that. That's how people did it before the bool data type was added to the language. 0 meaning false and 1 meaning true. And what you would often see people do is they would # define bool to mean int. They would # define false as a 0, and they would # define true as a 1. And so then you could do bool error equals false, and then if num is greater than whatever, error equals true. Yeah, don't need to do that. We have that in our language now. I'm going to delete those. I just keep showing you # define because for some reason that's stuck in my brain. Probably because the quiz question was what character begins a preprocessor command, and a lot of people put # include. No, the include is the command. It's the #, the hash, that marks it as being a preprocessor command. Logical operators. We've already talked about and I kind of mentioned or. And is two ampersands. it evaluates the true if both expressions are true. If both things on if the things on either side of the and are true. Both operands are true. Or it's true if either expression is true. Now, if you're an electrical engineer, you've heard of exclusive or. We don't have a symbol for exclusive or logically, but that would mean if one and only one of either side is true. But if they were both set to true, then it would not be. Yeah, don't care about that. And then not reverses the value of the expression, reverses the truthiness. Colbert used to do the word truthiness all the time. If it was true, it becomes false. If it's false, it becomes true. Now, you Python programmers had all three of these words, but for not, we're going to use the exclamation point. For or, we're going to have two vertical bars. And for and, we're going to use two ampersands. So truth tables. I really don't feel bad if y'all are typing in all of these notes. Whoops, that's a Python comment. /star. So if you have this, x, y, and result, and you have a true, excuse me, a false, and a false, and what are you testing? The and, right? So if you have false and a false, the result is false, right? They both have to be true. If you have a false and a true, the result is still false, because they both have to be true. If you have a true and a false, the result is a false. The only time an and can be true is when both sides of it are true. This is what's known as a truth table for and. Next, we're going to make one for or. X or y, and the result. False or false? No. At least one of them has to be true for the result to be true, right? Like I'm sick or I'm tired, but if I'm not sick or tired, then I don't get to stay home. So, a false or false results in a false. How about a false or a true? Well, I'm either sick or I'm tired, I get to stay home, so that's a true. And a true and a false. Well, only one side has to be true for the result to be true. And how about if they're both true? Well, good news. We still get to count that as true. So something to note about the truth table for and is that the only time it's true is when both sides are true. For or, the only time it's false is when both sides are false. Maybe that's a way to remember it. Or maybe you just have to remember the definition. Both sides have to be true for the result to be true. So that is the truth table for or. And then lastly, the not, right? Not x, right, and the result. Well, if x was true, then the result is false. And if x was false, then the result is true. That's all not does. Now, if we looked more closely at this, and we replaced all the f's with zeros and all the t's with ones, don't necessarily make this as you know. I'm going to undo it. Like that. Bitwise, underneath it all, that's all that, trues and falses are. Okay, 0 and 0, 0. 0 and 1, 0. 1 and 0, 0. 1 and 1, 1. Little thought problem. It's okay if you don't get it. What mathematical operation follows a similar pattern? Where if you give it two zeros, you get a 0. If you give it a 0 and a 1, you get a 0. If you give it a 1 and a 0, you get a 0. And if you give it two 1s, then you finally give it a 1. Multiplication. Exactly. So, and is considered logical multiplication. If you ever take a logic course, like you go to a four-year school and you're getting a degree in logic, then you will see long expressions written where multiplication means and so guess what? Or is addition. Now I'm not going to replace all of those. I'm not going to take the time to replace all the ones in the or table, but we can look at it, right? 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 1 equals
2?
Nah, it's still 1 because Boolean algebra is a math where you only have 2 possible values, 0 and non-zero. So 1 plus 1 would equal 1 in Boolean math. Why am I taking the time to point that out? Because it implies something about precedence. So I'm going to add a comment here. And can be considered akin to multiplication as logical multiplication. And or can be considered as logical addition. So if you had this phrase, 3 plus 4 times 5 plus 6. You know which one of these has to be done first mathematically, right? By precedence, do we do the addition or the multiplication first? Speak up. You don't do addition first.
No, you have
Yeah,
to
do multiplication.
You've got to do the multiplication first because multiplication has higher precedence on the operator precedence table. So you would do that one first.
29.
Yeah, okay, so 4 times 5 is 20, and then you add 3 to it, and that's 23, and you add 6, and that's 29. What if you had an expression like this? A or B and C or D. Well, if we treat and as multiplication and or as addition, then and has higher precedence. So that would get done first. Like that. That would be done first. It would be treated like that. If we didn't want to treat it like that, we'd better put parentheses to indicate exactly what we mean. Right? If we wanted it to be like this, we'd better put those parentheses there. So the and would be done first, and then the ors would follow. Because and, just like multiplication, is higher precedence than or, like addition. If there's ever any doubt, if you're ever writing a complex expression with lots of ands and ors, go ahead and use parentheses to make it clear. So when I say A or B and C or D, that's assuming that these are flags, right? That these are Boolean values that have been set. So, you know, if age is less than 10 or age is greater than 100 and insurance equals yes or wealth equals yes, because we're wealthy. Now, I don't really know what this means, but let's just roll with it, right? If all of that is true, then we get really good medical care. We get good medical care because we're young, or we get good medical care because we're greater than 100 and our insurance is equal to, okay, so how do we evaluate this? And has higher priority than the rest. So we would have to do this. We don't have to do that, but that's conceptually how it gets evaluated, is that this would be checked first, just like that's checked first. And then once that is evaluated to true or false, then we can check, see if it's less than 10, greater than whatever, like that. Now that example is so silly. I don't know about leaving it in there, but I guess if you typed it, you'd be peeved if I erased it. So I'm going to remove the parentheses here, and then I'm going to say is the same as, like that. I was hoping we'd get a little bit further. I talk too much. Y'all quite agree. So, x is equal to 12, y is greater than equal to 5, and z is equal to -4. Let's figure out if this is true or false. With x being 12, is x greater than y? Compare those two numbers and tell me if x is greater than y. It is. And is y greater than z? So, and with an and, they both have to be true for the result to be true. Are both of them true?
Yeah.
So the result is true. If I move the window over, we'd see that to be the case. Is x greater than y? Yeah, it still is.
It's the same thing as the other one.
And z greater than y?
Oh, my bad. No.
Okay, so is -4 greater than 5?
No.
No, so that's a false. Both sides have to be true for and to be true, so the result is false. Even though that one was true, this side is false, so the result is false because of the and. Okay, is x less than or equal to z? Well, is 12 less than or equal to z? No, so that side's false. Is y equal to z? No, so that side's also false. Or means one or the other. Well, neither are true, so the result is false there. How about that one? Is x less than z?
No.
No, but is y not equal to z?
Yes.
That's true. So although this one was false, this one was true, and or just means one side has to be true, so the result is true. And lastly, is x greater than z, according to this? Ignoring the not, is x greater than z? I think I hear a yup. And then, since that's a true, but that would turn it into a false. So that's a not. Logical operators, as I mentioned. Exclamation point has the highest precedence. I didn't mention that. Followed by the ampersands, and then the or. Now I'm going to stop here because I'm not going to talk about short circuit evaluation here. So for homework, now you're going to have 2 weeks for it. I don't want you to have to work over spring break. But, you know, if you don't get it done this week, give me your next one. So ask the user for the temperature. Ask the user for their urine output. Sorry, being weird. If the temperature is greater than 100 or their urine output equals 0, then we're going to tell them, go see a doctor. Else, tell them everything's great. And that's enough there. And let's do that. Else, tell them everything's okay. All right. Now we're going to do a grade scale. Not a grade scale. We're going to ask for the weight of the elephant.
Is this one program or two?
I would just stick it all in one. If the weight is greater than 2,000, it's a ton, so tell them it's a large elephant. Else, if the weight is greater than 1,000, element, that's what you were telling me. Tell them it's a small elephant. Else, tell them it's a micro elephant. Just silly stuff. Ask the user if, or for an amount of money and for an amount of hunger. And then go by this logic. If the amount of money is greater than 0 and the amount of hunger is greater than 0, tell them to go out and eat. Else, tell them to stay home. And lastly, ask the user for the amount of tiredness and the amount of sickness. If the amount of tiredness is greater than 0, or the amount of sickness is greater than 0, tell them to stay home, else tell them to go to work. So you're going to have 3 pairs of data that they're going to enter, or, well, plus the weight of the elephant. So, you know, you got that to ask for, then you're going to have some if statements. You're going to ask that, and you have some if statements. You're going to ask them for those 2 things. You're going to get some if statements after that and that. So this is going to require the use of if and else and or. Does that make sense? It'll be due Monday night, 2 weeks from today.
Make sure you post it.
Yeah. All righty, any questions? Well, let's stop. Make our Dropbox.